Good afternoon. Instead of discussing how to build superintelligence, and instead of giving you the secret formula of how to do it, I will, simply because it's too late in the day today, rather discuss whether there can be superintelligence. And so we got all used to these spectacular headlines, and I won't comment them in detail here because you've seen them all. But again and again, we see as well as humans can, or we see something like better than humans can. So in the case of MT, we know this stuff very well because I'm from language processing, and the people at Google are former staff people of ours, some of them at least. So, and voice computing is another case where people say that now some systems for some applications are better than humans. And because AI gets better than humans in some cases, for some tasks, people are immediately afraid, will they take all jobs away? But I won't discuss this. I will rather discuss today what superintelligence could really mean if it exists, and where can we expect it, and where is it pretty much impossible in the foreseeable future. So this was Werner Winge's theory, or that was his prediction in 1993. Within 30 years, we will have the technological means to create superhuman intelligence. Shortly after, the human era will be ended. If you look at the time, it's very close, or already due. And Stephen Hawking warns that robots could evolve faster than human race and could be hard to stop. I guess all these things have been discussed in the morning. I will take a slightly different angle. Oh yeah, and then of course we know that, every AI specialist knows who's really behind our research, yeah? Okay. So, and here also, it's Tesla's Musk also, it has to be Satan. So AI have started to penetrate all sectors of manufacturing and service industry, actually. And AI is now in many places in much less spectacular forms than AlphaGo and Deep Blue. But, and the magic is, of course, that an AI enables machines to do things that up to now only humans could do. So we think immediately, if only humans can do it, that must be AI, yeah? There are some things that humans can do, like reproduce other humans that may not be called AI, but most of the things that only humans can do are AI. So, but AI extends and enhances humans' perception and cognition, so far is clear, and I think you saw this in many of the talks, but the question is not, does it only enhance human cognition, or can it really be human cognition? And AI helps humans and machines to interact, so almost every respectable large company now has these speakers in your living room and tries to get into the, you saw the latest announcements, into the bedroom, the bathroom is coming, and so all these things, so you can talk. So why does the whole thing happen now? And I hope that has become clear from the morning talks. It is actually because 5 different things come together. There are 5 developments, and each of them is spectacular enough, but if they come together, something new comes up. So it is big data, both the availability of the big data, but also the availability of the technology for handling it. And then secondly, it's the breakthroughs in machine learning. You heard several talks in the morning on deep learning, but deep learning is not the only game in town. It's maybe the strongest one, but there's many, many powerful new methods of learning. And then, but then there is something I want to, that shouldn't be forgotten. At the same time, when there are these spectacular success stories of machine learning, deep learning, there's also very big knowledge accumulation, yeah? Think of the big knowledge graphs of Wikidata, the Google Knowledge Graph, and other big collections of formal knowledge. I will come back to that. then and some of the breakthroughs are due to the success in this area. Then there's, of course, internet technology, IoT, and web services. And then, of course, without the hardware, without the progress in hardware, all of this would not be possible today. That's all we know. And so it's mainly to go back. I will not, because there were several talks already, I will not now go into the deep learning itself, but much of the stuff that I will say actually has to do a lot with deep learning. Yeah? So it addresses deep learning directly. So now our question is there superhuman performance? And of course the answer is easy. In certain tasks it has been proven with Deep Blue in chess for quite a while ago, and IBM Watson, clearly IBM Watson was better than the two human quiz champions. Everybody could see that on television. And it was an extremely fair competition because none of the three candidates were connected to the internet. Yeah? So that was completely fair. There was one human, in the middle was the machine, and there was another human. Of course, the machine didn't fit into the seat, so actually the next floor below was also filled by the machine, and the machine was not connected to the internet, but it had downloaded half of the internet before. So it was a complete fair competition. So, and then you have also things like AlphaGo. Chess world champion was beaten. And Google's driverless cars, you know that the American authorities already determined 2 years ago that now the level of human driving has been reached, and they may not be driving as Michael Schumacher or Vettel, but they are driving much better than the average guy. So there is clearly superhuman performance. So is there then also superintelligence? And is what these machines do really intelligent? Or is it just big? Is it just like in the case of IBM Watson, tons of machines that can do what humans do without intelligence? The same thing has been said about Deep Blue. Of course, if you can build a computer that can calculate many draws, many moves in advance, and there can calculate all the consequences of these moves, then maybe you don't need to be intelligent, yeah? You just need to calculate. So this is an interesting question now. Is it intelligence really, or is it just pure computing power? So this is the driverless car, and this is the, let's come back to the doctor a little later. This is the doctor, but I'll come back to the doctor a little later. So there are actually the three big pros of artificial intelligence. And in your companies, you have to decide what to do. Yeah, the three pros are propaganda, processes, and products. So on the left is propaganda. This is things like, AlphaGo, IBM Watson, and in the beginning, it's lots of propaganda. But now, IBM Watson has become a core product, and Google has declared AI first, so it's moving from propaganda into products and processes. For most companies, it won't be the case that in the near future they may have an AI product, maybe a company that produces chairs or handkerchiefs or glasses. They may not put AI in there in the near future, but even there, AI can help quite a bit in cost savings, in automation, in customer relationship management, in business analytics, in logistics, production, maintenance, market research, and all these areas. And then, of course, it's products in AI and devices, in software and in cloud services. So, but still, we have to answer, what does it have to do with this thing here? And very often people like now to show a brain and draw parallels between the little cells in this brain and the neurons and neural nets, and think this explains already that we are getting close to the human brain. It's of course far from being true. The type of neurons that we have in the neural nets do not in the slightest, resemble already the high differentiation that we have in the human brain. So let's step back a little bit from the wetware, as we call it. Let's step a little back and say, what are the components of human cognition? And then go and see whether the AI systems already have them or whether they don't. So there's first, when we are born, we are already born with something, namely with innate instincts and capabilities. Those we owe to millions of years of evolution, before the humans were humans. So even a child is afraid of snakes, insects, we disgust body excrements, we have attraction to the other sex, we have emotions, and we have very sophisticated means for dealing with human faces. The baby will know that the mother laughs before it was trained like a neural nets on millions of laughters. So the baby knows this already, is born with the innate capability. So the second thing is acquired explicit knowledge. Those are facts, theories, methods. And then symbolic sequences and patterns. What's the difference? So the facts are the things that we have stored in the brain. We may not know exactly how to phrase it. Each time we repeat the fact, we may use different words. So it's not that we have stored the symbols, but we have stored something like symbols, namely concepts, pointers to certain things in the world. And then we can also remember a little bit of symbolic sequences, some songs, some formula, some sequences, some phone numbers, but we are very bad at this. So this is what we are very bad at. And you can already think about what the story will be. The computer is very good at these things. But the computer is also very good at storing facts. But we will come back and see what the difference is. And then the third one is that we have other acquired implicit knowledge, like our first language. So try not to listen to the next sentence I'm telling you. Please switch off your understanding. You cannot, because it's not voluntary. You cannot switch it off. And many people speak a language very well who don't know what an object or a subject or a verb phrase is. So that means it's also implicit language, at least the first language is, and then lots of procedural behavior. Let's describe to our children how we do swimming, breaststroke, and after we've described it 3 times, we push them into the water and go away, because they can swim then. So this doesn't work, of course. We know in this case, something like a neural net would be good, something training. So this is the parts of human brain. Now we can put this, we can split it up a little more sophisticated ways. We have the sensory processing first, then we interpret, then we do inference, then we plan, then we communicate, move physically, and so. And then there's also some reactive system, and this is actually the part that resembles most closely the learned behavior by neural nets. But I'll come back to that. And up there, this stuff, this is more the symbolic AI. And in the human brain, we have both. And the power of human cognition is that these are connected. So this is perception, this is action, this is unplanned, this is the inferencing part, this is language, and so on. And this is the affective system. The reactive system is most closely connected to the limbic system, to our emotions. Doesn't have to be that way, but it is that way. So it is the way. So now let's look at different types of systems in AI and machine learning. This is an old expert system for credit check, as American Express and others have used it for a while. It is built on knowledge, has rules, lots of rules in their logical systems. And this is a classical reactive robot control, programmed line by line. Now machine learning comes into play. And again, we get now systems on both sides. On the left side, we get things like IBM Watson, storing many books, tables, schedules, storing, lots of stuff. And chatbots are actually maybe a mix, because the knowledge they look up may be in tables, in texts, in rules, but when they use speech understanding, the speech understanding completely works with statistical and neural methods today. And for instance, our big data text analytics is here, but machine translation is on this side. That's strange, two language things on this side. But I mentioned earlier already, also humans use quite a bit the non-symbolic way of processing language, or the non-explicit knowledge. And so right now, the best method, but Google Machine Translation does not understand a single sentence, not even a word. But it translates because it has been trained on millions of sentence pairs translated by humans. And it is just like a parrot mimicking these humans. Yeah? So it's a very, very good mechanical parrot. So why doesn't that get together? Because in the human brain, that will come together. And actually, many people who work in this field will know that it will come together. Why? Because in our labs, all groups are working on it. They are not showing it yet at the big conferences, because this is the next wave, yeah? So right now, people get a paper if they can improve the F-score in some convolution neural net or GRU net by a few percentage points. But this is all not the important stuff. The important stuff, usually people don't talk about. The important stuff is who will be able to combine these things in a reasonable way. This will be the next revolution, not the improvements in F-score. So right now there are really different systems, as I showed you already, but these machine-learned behavior systems have no reusable knowledge at all. That's why we can build, on the one hand, systems that beat the Go world champion and can drive, but the driving system cannot translate, the translator cannot play chess, the chess player cannot do anything, cannot speak or understand speech. Each of these things are idiots. They can do one certain type of behavior. Now it is possible to connect two of them. People have done that and tried that. You get a huge neural net and you connect two. But this is not what humans do. If I'm driving and somebody tells me that the road is wet, or that somebody spilled oil here, or that there is a new traffic law in effect, then I can adapt my driving, because my learned behavior is connected to the knowledge I have. But this is not true for most of the statistical trained systems and for nearly all of the neural nets. So there are some in the lab that have some influence where you can steer and go in and change, but it doesn't scale yet. So they are completely free of knowledge, and they cannot explain why they do something. There's no grounding. Yeah, our knowledge is grounded. We only know something if we know the lower parts, its components, and can ground it in the end in everyday knowledge. So think of a doctor. I told you I will come back to the doctor, because we do lots of medical work in AI. I like doctor examples. So you know the situation that the doctor looks and tries to find out what's there. And the doctor cannot remember a single case, and the doctor cannot remember scientific literature describing something, but older doctors have very good intuition, especially general practitioners who have seen everything under the sun many times. So they have an intuition, and they cannot explain, but they say, must be this. I don't know why, and I knew some doctors of that sort. And such people I also met in companies. Yeah, so usually you get some old hands who are very experienced, who have very, very good intuition of things. Yeah? Now, our neural nets only have intuition. They have no knowledge. They only have learned intuition. So imagine somebody who was a doctor who was deprived of going to medical school, who never was allowed to read a medical book, but only learn from symptoms and diagnosis, from pairs of symptoms and diagnosis. And he got millions of these. In the end, he will be doing what the intuition doctor has. It's no knowledge, not in the sense that we talk about knowledge. It can also not explain why it does it. Yeah? So now there's a whole branch in neural networks, of course, that tries to get this knowledge out, because implicitly it must be in there. If we could now learn from these neural nets, if we could learn, then the neural nets would be able to maybe crank out the rules, better rules for the other doctors. And this is a whole branch in machine learning, actually, a very fruitful idea. Right now it doesn't work. So the difference is, for solving intellectually challenging problems, people need understandings and creativity. If we have understood a difficult problem, we have almost solved it. This is the first step to solving. Usually we cannot solve it because we don't understand it. If we have understood it fully, usually the solution is there. But these systems that don't understand a little bit, because right now their knowledge is not connected with the learned behavior, have a barrier at this point. So this is the problem now. So if we look at these components of human intelligence, then we know we have statistical learning of behavior in some systems. Those are the neural net systems. We get large reusable knowledge in other systems, like IBM Watson, or systems that are even more built on symbolic knowledge, on huge amounts of formal knowledge. And then we get a few inference capabilities, not yet far as good as humans, but we get some inference, and we get some knowledge acquisition, and intentions and planning a little, but no self-consciousness, no analogy reasoning, no sentiment, emotions, no creativity. And actually, a very good analogy reasoning is used for creativity, because if you look at any reasonable theory of creativity, analogy, really doing with analogy, is the basic building block, is a very basic building block of creativity. So this is not there yet. But on the other hand, in machine learning, I don't know if somebody talked this morning about transfer learning, because I couldn't, I had such a full day. I wish I could have listened to the talks, I could not. Transfer learning is a discipline within machine learning, also used heavily in neural net learning, that actually builds the mechanisms that can be used for analogy formation. So it is not that it was hopeless, learn analogy, it's not hopeless, but there's still something missing. And this is the drive that humans have for creativity. Because if you think of my earlier picture of the different, or list of the different components of human cognition, we are not born, we are not living by goals that are given to us intellectually only, but we have deep desires. Deep desires come from our instincts. They drive, they determine our goals. There's the limbic rewarding system. We get chemical rewards. Yeah, without these chemical rewards, we would be like some people who are very depressive, who need these rewards given in form of medicines, because otherwise we couldn't function at all anymore. We would be without any drive. We would kill ourselves. So we are really dependent on all of that, and there's no equivalent for that in the machine, and there won't be in the very near future, not even in the distant future. So, but assistants need to understand their masters. So it actually, bringing these two worlds together is absolutely necessary. This is, and I think many people, visionaries in the field, they know, and the reasons that you don't get more talks about it is because people cannot tell you yet. They want to be the one who tells you how to do it. So it's not that they are not aware of that need. So if you look now a little bit, and then I will conclude already, if you look a little bit in the growth of knowledge that we have now, because you all talked about neural nets on learned behavior the whole morning. Look at, so you know, this is the Wikipedia compared to the Encyclopedia Britannica, and then some of that knowledge gets formalized. This is a picture of the Google knowledge graph. So some of the knowledge of the Wikipedia gets transformed, and here you get your documents, and here you get your knowledge. You get your knowledge from the knowledge graph. And these knowledge graphs, as we are sitting here, are growing day by day by not just knowledge communities, but we and others develop software that also automatically now learns from texts. And there are just some number, for instance, the DBpedia, we are working in a project with them, with their stuff. They are now more than 1 billion facts. The Google Knowledge Vault, this is less secure. This is more secure knowledge, this is less secure knowledge. The knowledge graph at Google has the secure knowledge, the knowledge vault has lots of unsecure knowledge. That gets even higher, yeah? But it's not secured, so you get lots of this stuff. So now you can imagine how this stuff is coming in. Because you not only have the machine learning and the knowledge and the behavior that are learned, but you get something else. You get systems that can use data at runtime. Yeah, they can use data at runtime, the data from the outside. And the first step with neural nets will not be, although some people are thinking that you put all databases into the big neural net. Yeah? You put it all in, and then it's the biggest database and so on. But there's a more effective way right now, because the other thing is architecturally and from the efficiency not solved, yeah, is namely using these huge amounts of data at runtime. Yeah? Many systems can do that. And if the system has the access to this huge amount of knowledge, and us people, we only have this tiny head, yeah, like these poor guys who were beaten by Watson, yeah, we only have this tiny little ball here, yeah, with very little in here. And there is a machine, yeah, that has all that stuff in the world in there. It has more than 1 billion facts, has all the books in there, all the tables, all the... So, you can imagine, at this point we are going to lose, yeah. And the system will still not have the drive, yeah. So, this is actually where the superhuman capacity will come up, and it is already coming up. And this is where things will happen very, very fast in the next years. Still, we won't have, my prediction is we won't have the Hollywood bad, evil AI that comes and are looking where does the human have the switch off button. Yeah, so how to switch off the humans. And the evil AI that wants, because I told you already earlier, all these things, self-consciousness, own drive, all these things are not there. The systems are not reflective enough. They don't have models of the world and of themselves yet. But in their decision-making and in their support for human decision-making, they will be much more powerful than us in a hopefully very benign way. Why? Because they have access to all the knowledge in the world. Yeah, we can already build robots that go around and can tap into the knowledge vault or into DBpedia, know everything about the thing. But there's one more thing that maybe was mentioned in the morning, but I'll repeat it in case the speakers in the morning ran out of time before mentioning it. Yeah, could be. And this is the following. In our case, one part of our knowledge has undergone evolution. Our knowledge has undergone a couple of thousands of years of evolution because the symbolic knowledge gets passed on from generation to generation and can be added to. But if a pianist dies or a very world-famous driver, race driver, then its behavioral knowledge is gone. Yeah, is gone at the point of death. And so that means there is, when it comes to a dancer, a driver, there's always a limit. Yeah, that has to do with the life cycle. Has to do with the life cycle. At some point you cannot learn more, you can only learn from, and also you have limitations of your own neural system. But the thing is, with these neural nets that were discussed in the morning, you don't have this anymore because you can copy them. Yeah? You can copy them like we copy our symbolic knowledge, yeah? In books, in tables, and so on. So that means it can grow over generations, or it can be implanted in many devices and learn at many places in the world. So the learning actually is also much, much more powerful than in any other system. Okay, so I think I'll finish with that because I think that explains a little bit what I have to say. This is a modified slide by Wolfgang Wahlster, who is the CEO of the DFKI. He sees this as the main phases of AI, because we tend to think AI is something very new and cool, but actually it is old and much cooler. So it's so this is the phases. It started with the heuristic systems, put everything into the program, then the knowledge-based systems, then the machine learning, and I just adapted the numbers because I disagree with Wolfgang Walster on the times, but I agree on the phases. And now the next system is, and I don't mean now IBM here with cognitive systems. IBM seems to have bought the term cognitive someplace here, but I don't mean that. I really mean what I showed you earlier, namely the integration of the two worlds. Okay, and let me finish then. I think if we manage to get to this point, then we can activate immense economic reserves, because all of our processes in society are very wasteful still. And it will be a sweeping augmentation, not a deletion, an augmentation of human cognition. And probably also discussed, it will be liberation from alienated labor, and to transfer labor to non-alienated labor is a difficult task, but we cannot discuss it today here. It will perfect service knowledge society and accelerate the evolution of knowledge. We already have very fast acceleration of knowledge, but this will double and triple again. And it will lead to better, longer, and safer life. Thank you very much.